students, it's me and I'm back with part 4 of section 5.2. Today we'll be looking at how do you solve using the idea of a conjugate. Again, that core objective that we will be focusing on throughout all of these lessons is I can simplify to show the left-hand side is the same as the right-hand side. Today's extra objective is I can use conjugates to finish the proof. Let's go ahead and jump in. To begin today, we will be reviewing our core trig proof tips and tricks. So the first 3 should be very familiar to us. That's begin with the more complicated expression, try changing everything into sine and cosine if you get confused, and combining fractions by getting a common denominator first. Yesterday, we reviewed how to factor so you can reduce, and we talked about looking for the difference of 2 squares. Today, we're going to talk about multiplying by the conjugate to get a Pythagorean identity. Really, parts 4 and 5 kind of go together. They're very similar in their nature. So let's talk about conjugates. What is a conjugate and what does it look like when you multiply by one? Well, if you recall, a conjugate is when we have the positive and negative, or a positive and a negative of the second term. When you multiply it out, you end up with a difference, or sometimes not a difference, but you end up with that 2 squares showing up. The middle terms always add out to 0. So in A, the conjugate would be 1 plus secant of x. Notice that this was a minus. Let me grab my highlighter for us to see that better. This is a minus. This part's a plus. That's the conjugate. Everything else in the problem stays exactly the same. If I were to then FOIL this, I would get 1 plus secant of x minus secant of x minus secant squared of x. Simplifying the middle terms, adding to 0, we get 1 minus secant squared of x. Now, just for the fun of it, because we're practicing our identities, this one should resemble one of our Pythagorean identities. This would be 1 plus tangent squared of x equals secant squared of x. If I rearrange this, I would be able to say 1 minus secant squared of x is equal to negative tangent squared of x. So I could go ahead and state that, well, this whole thing, if multiplying by its conjugate, becomes negative tangent squared of x. Let's look at another one. What is the conjugate of sine x minus cosine x? Hopefully you said sine x plus cosine of x. Again, noticing that we have the positive and the negative showing up. Let's go ahead and FOIL this just to see what we end up getting. In FOILing this, we get sine squared of x plus sine x cosine x minus sine x cosine x. That's the inside 2 terms. And then we have minus cosine squared of x. Again, when you multiply by that conjugate, notice the middle term should always add to 0. And in this case, it leaves us with sine squared of x minus cosine squared of x. Now, this is not an identity. It could be rewritten, but it's not going to be able to be rewritten in a more simplified version. So we'll stop there for this one. Today, I have 2 additional examples practicing utilizing this conjugate method. So we want to prove the following identity. All right. As we look at this, I, again, always like to start off with left-hand side, right-hand side. Which one is more complicated, or which one do you want to work with? Now, technically, we could work with either side. Because the bottom of the left-hand side is a little more complicated and denominators are harder to work with, I'm going to go ahead and say I'm going to work on the left-hand side first. All right, so looking at this and knowing that these problems are practicing utilizing the conjugate, I can't do any simplifying or replacing because nothing is being squared. So let's insert a squared term into it. Let's multiply by the conjugate of the denominator. Now, notice I'm not doing this to both sides. I'm doing it to the left-hand side, and I'm doing the same thing to the top and bottom, which is what makes it a legal move. Now, when I do this on the top, I'm going to leave it as 1 plus sine x times cosine of x. Some of you might be tempted to want to distribute that. I strongly discourage it, and the reason I discourage it is because I want to be left with a 1 plus sine x on the top. So I don't want to distribute it. I'm going to have to undo it eventually, most likely. I am going to expand out the denominator though, and I'm going to go ahead and do that on my reasoning side. So I would have 1 times 1 is 1. And then I have 1 times negative sine x, which is negative sine x. 1 times positive sine x, which is sine x. And negative sine x times positive sine x, which is negative sine squared of x. In simplifying this, again, we know those middle terms should add to 0 if I did it correctly. I am left with this statement. Now, because I've already told you, oftentimes these are going to produce the ability to use one of our Pythagorean identities. I go ahead and I grab my Pythagorean identity that has a sine squared in it. And I acknowledge that if I were to subtract the sine squared over, I would get 1 minus sine squared of x. Let's replace. So I have 1 plus sine of x on the top times cosine of x. And on the bottom, I have cosine squared of x. Now, you might say, Ms. Vernon, I'm really not seeing how this is going to become this on the right-hand side. But notice that because I'm multiplying the terms on the top, I have the ability to reduce out one of our cosines, which leaves me with 1 plus sine x on the top and cosine of x on the bottom. Just like that, you finished the proof. Again, you know me, I like to end with a happy face. We just survived another proof. Let's go ahead and do one more example. All right, in this problem, it says, use your identities to prove the following. All right, well, let's begin. I don't see a whole lot of conjugates here, but maybe we do. As we look at this, we have a couple different options. We have the left-hand side and we have the right-hand side. Now, there are many ways to do this. I would argue that the left-hand side is more complicated, but I would also argue that we're talking about conjugates and the right-hand side does allow for us to multiply by a conjugate. So let's work the right-hand side with that conjugate notation idea in mind. So on the right-hand side, I am going to multiply by 1 plus cosine of x. And if I do that to the bottom, I need to do that to the top in order to keep it balanced and follow my mathematical rules. All right, in doing this, on the bottom or in the denominator, I would end up with 1 plus cosine of x minus cosine of x minus cosine squared of x. Again, those middle terms canceling out leaves me with 1 minus cosine squared of x. I'm also going to multiply out the top. Now, for the top, I am going to rewrite it because I feel like that will help many of you track with me. And when I do this expanding or foiling, I get 1. 1 times 1 is 1. 1 times cosine of x is cosine of x. Negative 4 cosine of x times 1 is negative 4 cosine of x. And negative 4 cosine of x times cosine of x is negative 4 cosine squared of x. Combining those middle two terms allows for me to get 1 minus 3 cosine of x minus 4 cosine squared of x. Well, friends, that's the numerator of the left-hand side. All right, we are making great progress. Now we just need to figure out the denominator. Well, I see that squared, so I instantly think sine squared plus cosine squared equals 1. And if I move that cosine squared over, I get sine squared of x equals 1 minus cosine squared of x. So the denominator can be replaced with sine squared. And after replacing the denominator, it allows for me to see that I end up with the same thing as my left-hand side. Just like that, multiplying by the conjugate to the rescue. I hope this helps you see how to work with this. Now, in this particular problem, we also could have factored the numerator of the left-hand side and looked to reduce that way using that factoring or step 4 idea. But because the nature of this lesson was to talk about conjugates, I decided to teach it through the conjugate lens. There are many ways to do this particular task. Keep an open mind. My way is not the only way. It is one way of many that you can solve these problems. Stay tuned. We have one more practice lesson, and then you'll be all set with all the skills you need.